Implementation of indirect ELISA test, example of ELISA Trypanosoma evansi, species tested, Camel. Refer to the detailed protocol for references of reagents to be used for this ELISA and especially for buffer preparation. Step number 1. Coating of the antigen. Resuspend the lyophilized antigen with 10 ml of coating buffer, carbonate buffer 9.6. Composition is Na2CO3 1.8 grams, NaHCO3 2.93 grams. Sufficient quantity for 1 liter. pH is adjusted at 9.6. Vortex the diluted antigen. Distribute 100 microliter of diluted antigen per well in the ELISA plate at the exception of wells A1, A2. Seal the ELISA plate and incubate overnight at 4 Celsius degrees. Step number 2. Preparation of the blocking buffer. Blocking buffer is made with 0.75 gram of casein, 100 ml of PBS 7.4 and 3 microliter of Twin 20. Keep overnight for incubation at 4 Celsius degree. After one night of incubation at 4 Celsius degree, step number 3, blocking of the ELISA plate. ELISA plate is unsealed. Remove the solution by turning over the ELISA plate and bang on absorbing paper. Place 150 microliter of blocking buffer into each well at the exception of wells A1 and A2. Hold the multi-channel pipette at an angle of 30 degrees to avoid air bubbles. Sealing of the ELISA plate and incubation for 30 minutes at 37 Celsius degree, 300 rotations per minute. Step number 4. Serum dilution. You will need blocking buffer, control serums, serum samples test, a U-bottom plate and cone. Label the dilution plate, a U-bottom plate, to facilitate sample identification. Then place 147 microliter of blocking buffer per well at the exception of wells A1, A2. Vortex the serum samples before pipetting. Introduce 3 microliter of serum, either control or sample, per well containing the 147 microliter of blocking buffer. The dilution is 1 in 50. Remove the ELISA plate from the incubator, remove the sticky transparent film and discard the buffer by turning over the ELISA plate. Bang on absorbing paper. Step number 5. Distribution of the diluted serum in the ELISA plate. Distribution of diluted serum in an ELISA plate is made at the exception of wells A1 and A2. First, distribute 50 microliter of blocking buffer. Second, distribute 50 microliter of diluted serums, mixed by pipetting in and out gently 5 times and transfer 50 microliter of diluted serum into the ELISA plate. Change the cones between each sample column of the U-bottom plate. The final dilution is 1 in 100. Sealing of the ELISA plate and incubation 30 minutes at 37 Celsius degree, 300 rpm. Step number 6. Washing of ELISA plate. Using plate washer and washing buffer. Remove the ELISA plate from the incubator. Remove the sticky transparent film. Discard the buffer by turning over the ELISA plate. Fill the plate with washing buffer. Remove the buffer by flipping. Repeat this step 2 times, 3 washes in total. After the last wash, bang on absorbing paper. Step 7. Preparation of the conjugated antibody. Dilution of the antibody as recommended by the supplier, in our case 1 in 3000 dilution, in PBS 0.2% twin 20. Step number 8. Distribution of the diluted conjugated antibody into the ELISA plate. Introduce 100 microliters of diluted conjugated antibody per well in the ELISA plate, at the exception of wells A1 and A2. Sealing of the ELISA plate. Incubation 30 minutes at 37 Celsius degree, 300 rotations per minute. Step number 9. Washing of ELISA plate. Remove the sticky film, discard the buffer. Fill the plate with washing buffer. Remove the buffer by flipping. Repeat this step 3 times for a total of 4 washes. After the last wash, bang on absorbing paper. Step number 10. Distribution of substrate chromogen in the ELISA plate. Introduce 100 microliters of K-blue substrate per well at the exception of wells A1 and A2. Incubate 30 minutes in a dark place at room temperature. Step number 11. Reading of ELISA plate. Reading the ELISA plate is made at 620 nanometers in the ELISA reader. Step number 12. Data analysis. The optical densities provided by the ELISA reader are exported to the Excel file for data analysis. Results are expressed in RPP, relative percentage of positivity, calculated as follows. Mean optical density of the samples minus mean optical density of negative controls divided by mean optical density of positive control minus mean optical of the negative control. The RPP of each sample appear in the RPP column of our pre-programmed spreadsheet. Interpretation of the test negative-positive is shown in the column cut-off line COL. A sample is positive when its RPP is above the positivity threshold, and it is negative when the RPP is equal or below the positivity threshold. End of the protocol. Thanks for your attention.